So look at number 3 from your homework. We know that the standard form of an ellipse has to be equal to 1, so we need to get rid of that 400. And we do that by dividing everything by 400. Okay, when we divide these, we don't just put this in our calculator, but we want to simplify this 16 and this 400. We want to simplify it, okay? It simplifies to what? 25 in the denominator, 1/25th, right? So this becomes x minus 2 squared over 25 plus y plus 5 squared over 16, and that's equal to 1. Are there any questions so far? Okay, please remember that next we need to determine the center. The center is HK, as you can see in the standard form. So the center is going to be 2, -5. Any questions there? All right, A is the square root of the larger number. So is A, what is A here? 5, very good. And B is 4. All right, the length of the major axis is just 2 times. If you were not here yesterday, please change this. There was an error on the key. The length of the major axis is 2 times A, and of the minor axis is 2 times B. So if you were not here yesterday, that would be Alexia, Patricia, Sierra. Please make that change to your notes. Thank you very much. The next thing, so the length of the major axis is really 10, and this is 8. Any questions? The next thing we want to do is we want to graph this. And to graph this, we're going to start with our vertex, our center, which is 2, -5, 1, 2, 3, 4, 5, okay? Our major axis, the bigger number's under this x, so that means that it's going to be stretched longer. Please listen. It's going to be stretched longer along the x-axis. So we're going to go to the right, 1, 2, 3, 4, 5. To the left, 1, 2, 3, 4, 5, okay? 4 is the minor. I guess the minor is 8. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so then we're just going to try to sketch this ellipse. So that's not like the prettiest thing I've ever seen or drawn, but you're getting the idea of kind of what this looks like. It's a little bit longer horizontally than it is vertically, right? Yeah, that matters. It matters which way you go, yeah. Because if remember, if the 25 were under the y, then we would have gone up and down 5 instead of right and left 5. Does that make sense? Right, since the 25 is under the x, that tells us to go right 5, left 5. If there were a 49 under x, we'd go right 7, left 7. Okay? Do you understand? Then we'd go right 4, left 4, and then we go up 5, down 5. Okay? So the vertices are the vertices of the major axis, okay? Which is this one, the horizontal one. So the vertices are these 2 points right here, which would be -3, -5. And it would be this other point, which is 1, 2, 3, 4, 5, 6, 7, negative. All right, and then the co-vertices are the 2 vertices right here and here. So that would be 2, 1, 2, -1, and 2, -9. Raise your hand if you have a question about that problem. Yep. Right, perfect. As the co-vertices, right? Right. All right, Alyssa, do you have a question? All right. Hold on. Okay, so let's continue, and let's look on the other 2 homework problems. So on number 6, we just want to divide everything by 36. And that gives us x squared over 6 plus y squared over 4 is equal to 1, correct? Are there any questions so far? What is the center here?
0, 0.
0, 0. Okay, what is A?
3.
Is the square root of 6 3? The square root of 6. Please pay attention to this. A is the square root of 6, okay? And what is B?
2.
B is 2. Okay? The square root of 6, that's approximately what? 2.4? Okay, so then what's the length of the major axis? Right, or if it would be kind of hard for us to graph 2 square roots of 6. Could I say 4.8? Cool. And what about the length of the minor axis? Good. Let's go ahead and graph these. What's our vertex?
0,
0, 0. All right, and then which way do we go 2.4? Right. The reason we go right is because the 2.4, the square root of 6 is 2.4, and that's under the x, okay? So we go right 2.4. We go left 2.4. And then we go up 2 and down 2. Ooh, I struggled with that graph a little bit. Our vertices are going to be negative 2.4, 0, and 2.4, negative 0. I'm sorry, 2.40. That was silly. 0, 2, and 0, negative 2. Are there any questions? Yes. Yeah, they just don't line up. Some of the problems required more space, so I gave you more space, but then all the graphs are the same size.
Wait, shouldn't it say 2, 0 and 2, 0? Because you plotted them right here. Like,
These points right here, those are 2.4. So that's why the vertices got 2.40 and negative 2.40. But then on the y, these would be 0, 2, and 0, negative 2.
yeah.
Yes, ma'am. No, the vertices do not. Oh, yes, I'm sorry. Yes, the vertices always go with A because A is always the largest. So, but the vertices could be vertical, like up and down, or horizontal, right and left. Does that make sense? Do y'all see that? Okay, let's do, number 7 is very similar to the ones we've done before, but number 8's a little different because it involves completing the square. So would y'all be down with number 8? All right, so in number 8, what we want to do is subtract 76. So let's just go ahead and subtract it over here. And then we want to start factoring or writing this out so that we can use completing the square. So that's 25. Okay, so what we did is we saw this 25x squared and this 100x squared, and all we did was factor the 25 out from that, okay? And now we need to complete the square. We need to complete the square for our x's, and we need to complete the square for our y's, okay? Please pay attention. So in order for us to determine what goes in this blank, we have to do b divided by 2 and square that, please.
4.
All right, so we have to do b divided by 2 squared, so 4 divided by 2 squared would give us what? 4. Good. So, but the thing is even though this is 4 here, we're distributing that 25. So that's not really a 4. What is it really? 100. So we need to add the 100 over here. Do y'all see that? Because that 25 is going to be distributed, so that's not really just a 4, it's a 100. Now we need to do the same thing over here. What do we do with this negative 2?
Divide by 2.
And then? And that gives us 1. Okay, but since there's nothing, this really is a 1 here, correct? All right, so then we can rewrite this as a perfect square trinomial. All right, and that's equal to, I think, what, 25? Okay, what do we do now? Divide by 25, perfect, because we want to get 1 on the right side. Is that cool with y'all? Okay, so what is our center?
-2, 1.
-2, 1. Very good. And John, what is A?
1.
Well, remember A, it's not always under X. A is the greater number that we're dividing by. So what would that be? Well, there are only two numbers that we have to deal with. We have a 1 here, and then we have 25 here, right? 5, perfect. A is 5. Do y'all see why A is 5 here? Right. And then what's B? What's B? 1. The length of the major axis? Length of the minor axis? 2. Because remember, it's 2 times B. Now let's graph this. We go to -2, 1. And then, are we going to go up and down 5 or right and left 5, Patricia? Why? The Y is up and down, right? So that's why it's up and down 5. But do you see that? Okay. So we go up 5, 1, 2, 3, 4, 5, and then we go down 5, okay? 1, 2, 3, 4, 5. How many do we go right and left? 1 right and 1 left. And these 4 points I just plotted, those are going to be our vertices and our co-vertices, and that's in that order. The vertices are the ones furthest away from the center, and that's going to be -2, 1, 2, 3, 4, 5, 6, -2, 6, and -2, -4. Is that right, Murphy? And the other ones would be -3, 1, and -1, 1. Right? So then we just have to try to make these look like an ellipse. Okay? Any questions? Oh, yes. Any questions? Excuse me. All right, what I'm about to hand out for you guys is going to be the this is not the entire study guide. There are actually 146 questions on your semester exam study guide, and this one only has 40 on it, okay? You will get the rest on Monday, and I will post the full study guide on Schoology in case you get a wild hair and just really want to work on it this weekend. But please know, we have the rest of today. We have Monday, we have Tuesday, and we have Wednesday. And that's it. We don't really even have Thursday because that's awards day, right? And exams begin on Friday. So we really need to hit the ground running because 146, that's a lot of problems. And we have a lot of information to cover. I think a lot of it you guys have probably forgotten, like inverses and rational functions.
Tell me stuff on the second section.
Yes.
And did you say 40 on the exam, like the real exam or the study?
There are 40 on this beginning part of this.
Oh, beginning.
I remember I just said that. I said I would give you the rest of it on Monday, but I'm going to make it available on Schoology, so if you really want to look at it this weekend, you can. Yeah. What is that? You don't want it? Well, I'll see if somebody wants it. Hey, can I sit there, please, ma'am? Thank you. All right, guys. Hey, we're still recording, and I'm not gonna go like too fast, but I'm not waiting on you to talk and play with your cell phone, okay? So, here we go. So remember inverse functions. The first thing that we want to do is we'd want to start with what we kind of call the vertex point, the HK point. Who can remember what that point is? Is it what? 3, 2, right? Now, if we picked a number less than 3, what would happen? What happens if we pick a number less than 3? 3. 3 is 1. 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 Well, let's try. If we picked 2, what happens if you plug 2 in for x? You get a negative under the radical, which is not a thing. Okay, it's undefined there, so we can't go any lower than 3, so we're going to have to go higher. Pick a number higher. 4. Okay, when you plug in 4, what do you get? 4 minus 3 is? Square root of 1 is? Plus 2 is? Good. Now, next we could go with 5. Why don't we want to go with 5? Right. It's not a perfect square. Can we think of a number that'll give us a perfect square? 7. Let's try 7. What happens if we plug in 7? 7 minus 3 is? Square root of 4 is? 2 plus 2 is? 4. That worked out nicely. Any questions so far?
Why did you choose 3, 4, and then went straight to 7?
Because we wanted a perfect square, and if we plugged in 5, that would give us like the square root of 2, and we didn't want to have to deal with decimals. So if we plugged in a 7, we knew that would give us a perfect square under the radical. Okay?
On these, we're looking for a perfect square.
Well, not on all of these. It just happens this specific problem because it's a square root function. Okay? Cool? So let's go ahead and graph this. Go to the right 3, go up 2, right 4, up 3, right 5, 6, 7, up 4. So our graph's going to look like this, right? Domain, how far left does this go? 3, so it's 3 to infinity, and our range is going to be, how low does it go? 2 to infinity. And the bracket is very important here because both of the points 3 and 2 are actually on our graph. 3 is in the domain of this function, and so it's 2. 2 is in the range, I'm sorry. Any questions? Now, to find the inverse, what we're going to have to do is actually switch our x and y, right? So in this equation, I'm going to write x is equal to the square root of y minus 3 plus 2. Okay? Subtract 2. Okay, then we're going to square both sides. And then just subtract 3 from both sides. And this will give us y is equal to x minus 2 squared minus 3. That was minus 3. We would add it. So it's actually, there we go. I accidentally wrote minus 3 instead of positive 3. Are there any questions on how I got that equation? If there are questions, it's okay to have questions, but you have to ask me. John. If you have questions, please let me know. Any questions? Okay, let's look at the, do we even, or we need to graph this, right? Now to graph this, what we can do is we can know how to graph a parabola, but this is actually not the full parabola. So if we took the inverse of these points, we just switched our x and our y coordinates. So we go to the right 2, up 1, 2, 3. We go to the right 3, up 1, 2, 3, 4. Go to the right 4, up 4, 5, 6, 7. So our graph looks like this. Okay? And we know that, or you can kind of like figure out if you made a mistake or not, because we know that all inverses are just a reflection of each other. A function and its inverse, they're the reflection of each other across the line, y equals x. And y equals x is this line. You don't have to draw this line. I'm just drawing so that you can see it. But do you see how if I were to take my paper and literally fold it on that line, our graph, our original graph and its inverse would just match up onto each other? That's how we know we didn't make a mistake. And we can look over here to find the domain and range. It's just the opposite. So the range is the domain and the domain is the range. So this is 2 to infinity, and this one is going to be 3 to infinity. Any questions? All right, so we are going to do very similar, same thing on number 2. So this is a parabola, and we're going to start with our vertex, which is -3, -1, correct? Now, when we're graphing a parabola, we want to pick a number 1 less and 1 greater, right? So that would be -4 and -2. And when we plug in -4, what do we get? -4 plus 3? 0. And when you plug in -2, you also get 0? So I'm just plotting our points. And our parabola looks something like this. Maybe not as ugly and a little more symmetric. Oh, hello, Azariah. I'm recording, I forgot. You can say hey on the recording, it's okay. Hey. All right. Me? I know, I'm sorry. I know. It's just a gift. So the domain is going to be -infinity to infinity, and the range is -1 to infinity. Do you all agree with that statement? Make sure that you're checking me. Any questions? All right, let's switch the x and y and then solve for y. So then this is x is equal to y plus 3 squared minus 1. We would add 1 and get x plus 1 is equal to y plus 3 squared. Take the square root. It's plus or minus the square root of x plus 1. Any questions? Oh, I bet you he was coming to get his cord. Oh, just kidding. Any questions so far? Okay, to graph this, we just need to flip our x and y coordinates. And I'm going to graph these. So 0, -1, 2, 3, 4. And remember, this is just the reflection across this line, y equals x. Can you guys see how that you visually can kind of tell that what we did was the right thing? Yes? And the domain and range are just flip-flopped. Any questions here? Please let me know if you guys have a question. Raise your hand if you need another minute to write this down. All right. Everybody please turn on to the next page. Okay. Remember y is equal to a times b to the x. Like that's kind of our standard simple exponential function where a is going to just be like your initial amount, what you're starting with. B is your growth or decay factor. And x would be your time. You could put a t there if you want. So if the price of a new house is $129,000, that's going to be the initial price or the starting amount, and we're going to multiply that times, if it appreciates 6%, that would be 1.06 to the power of 6. Do y'all remember that? If it were 60%, then that would be 1.6, but 6% is 1.06. And what would you get as your final answer? Anyone? 988.97, is that right? If it says to round to the nearest hundredth, is it 0.97?
Yeah, it is.
Okay. So it's $182,988.97, correct? Okay, y'all can do 5 and 6 on your own. Those are very similar. Look at number 7. So, it says half-life. Now, our formula for half-life, it's really like the amount remaining is equal to I, and I represents the initial amount. Alexia. I represents the initial amount times 1/2 to the power, and then it's of the days divided by half-life days. So that's D over H, days divided by half-life days. So it's really the same thing. The starting amount times the decay factor, and the decay factor here is 0.5 because it's being cut in half. And then the only thing that's different is that you need to remember it's to the power of days divided by half-life days, okay? So our initial amount is 145 times 1/2 to the power of days. How many days? 26 divided by half-life days. And what does that give you guys? 51.77 or something like that? 57? Anybody? What is it? 51.78 milligrams. Any questions here? Yes. Mm-hmm. Number 5, if it depreciates, it would be 0.88 because you subtract from 1. That was a good question. Did you guys hear her? Did you hear Caroline? I know that we just ate lunch and we're all comfy and sleepy, but we need to try to stay awake. Okay? Let's look at number 9. Oh, you remember? Good. I'm going to write the regular form for those of us who don't remember, okay? This is for an exponential equation. Y is equal to AB to the x minus h plus k. Okay? Did y'all see that? Now h. 1. And then we want a number less than 1 like 0 and greater than 1 like 2. Perfect. And then we're going to plug these in for x, right? So when we plug in 0, that's 4 to the negative 1. What's 4 to the negative first power? Do y'all remember? 1/4 or 0.25, right? So then we have 1/4 minus 4, and that's just negative 3.75. Cool? Now when we plug in 1, we get 4 to the 0 power, which is, and then 1 minus 4 is negative 3. Very good. And when we plug in 2, we get 4 to the first power, which is 4, and then 4 minus 4 is 0, okay? Very important thing when we are graphing exponential functions is to know what our horizontal asymptote is. And our horizontal asymptote is just k. So what is k? Negative 4. So our horizontal asymptote is y equals negative 4. Okay, and I'm actually going to draw your horizontal asymptote with a highlighter. So negative 1, 2, 3, 4. All right, that means that our graph is never going to cross that, right? So let's graph 0, negative 3.75, 1, negative 3, and 2, 0. So our graph comes down here and it gets really, really, really close to this pink line, but it never actually goes across it. Okay? So our domain is unrestricted, negative infinity to infinity, but our range is restricted. The lowest it goes is negative 4. And why am I using parentheses here? Right, so the lowest it goes isn't actually negative 4 because it never gets there, okay? And that's what that means is there's no number we're going to be able to plug in here for x that will give us 0 here so that this can be negative 4. It'll get really, 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 really small, but still not close enough to 4 to be 4. Negative 4, I'm sorry. Any questions here? All right, number 10, same thing. What do we start with? H, which is? Negative 1. The number less? And 0 is greater. Very good. When you plug in negative 2, you get 1/3 to the negative first power. And what is that? What is 1/3 to the negative first power? What? 1/3. Yep. And then you multiply that times negative 2 to get? Negative 6. Very good. Excuse me. What happens when you plug in negative 1, though? You get 0. Right, which is just perfect. And then what about 0? Yes? Negative 1 is H. We started with H and we picked 1 less and 1 greater. Because that's how we found it? Yes? Okay. Now, when we plug in 0, we know there's a negative 2 out front, but then we have 1/3 to the first power, which is just 1/3. So this is negative 2 times 1/3. When we multiply fractions, we just multiply the numerators and the denominators. So what is negative 2/3 as a fraction? I'm sorry, as a decimal, we could just say negative 0.67. Okay. And what is our horizontal asymptote? Alexia. What is our horizontal asymptote? Y equals 0? Good. I'm going to go ahead and draw that. Ends up just being our x-axis. Oh, that was not a straight line, I'm sorry. So negative 2, negative 1, 2, 3, 4, 5, 6, negative 1, negative 2, 0, so something like this. Domain is unrestricted. But our domain only goes from negative, our range goes from negative infinity to 0. Any questions here? Excuse me. No? Okay. All right, so really quickly, let's look at number 17. Do you guys remember how to go and write this in exponential form? We can just say this is equal to x, so then that would be 5 to the x power is equal to 25. Do y'all remember that? So this would be 3 to the x power is equal to 1. And we're not done with these problems, but right here this would be 16 to the x power is equal to 4. Do y'all remember that? I'm going to do one more. This would be 2 to the x power is equal to 1/8. Do we remember this? Okay, now go back to the graphs. Go back one more. I'm sorry. And look at number 13. So on number 13, I can rewrite this as 6 to the what power? To the y power is equal to, and I'm just going to say x, because we're going to do our shifts later. Remember, you might start remembering this in a second, but we're going to go ahead and just do the basic graph of log base 6 of x, and then we're going to shift it. Right. And the thing is, this is so weird, but really what it is, it's just the inverse of an exponential function, right? That's all we're doing is we're inverting that exponential function. We're finding the inverse of that. So for our y values, we're going to pick the points -1, 0, and 1, and we're always going to pick those points. And we're going to plug these points in here into this equation. So 6 to the negative first power is what? 1 over 6, which would be what? A decimal, some decimal? 0 point what? 17. Okay, and then when we plug in 0, we get 1. And when we plug in 1, we get 6. And that's the thing, 1 over the base 1 in the base. Right? Now we have to look at our shifts. Do we have any shifts? What are our shifts? Right, so what does that 1 tell us? Do we go, what? Right 1. Because remember, it's minus. Okay, so right 1. If we go right 1, that means we're just adding 1 to our x's, correct? So this becomes 1.17, 2, and 7. And now all we have to do is just graph these, right? So 1.17, negative 1, 1.17, negative 1, sorry. 2, 0, 7, 1, okay? And our h is going to be our vertical asymptote. So that's going to be x equals what? Is h 0 or is h 1? 1. Do y'all see why h is 1? Yes? So that's this vertical line here. I'm sorry? H is 1 because it's x minus h and then plus k. So here, h is negative 1, k is negative 3. Do you see? So this is going to get so stinking close to this pink line, it's going to look like it touches it, but it actually doesn't. And if we look back at these graphs, do you see how this is the exponential? This is an exponential graph, and this is just the inverse of it, okay? The domain is restricted here, so that would be 1 to infinity, and the range is unrestricted, so it's negative infinity to infinity. All right, let's try to get one more in. So we can rewrite this. How do I rewrite this? As 5 to the what power? Yes, ma'am. Would you not use a what? You wouldn't use a bracket because we're not actually getting to that asymptote. That's why there's an asymptote, because we're saying, you know, we'll never get there. This is 1.17, and then as we go lower, we're going to get closer and closer to it. It might be, you know, like 1.16, 1.15, 1.14, and just closer, and 1.000, but it's never going to get there. Does that make sense? What? Yeah? Okay. So this is 5 to the what power? Y is equal to x. Good. What goes here? Negative 1, 0, and 1, correct? And this is 1 over the base, which is 0.2. This is 1, and this is the base, which is 5. Now, what are our shifts? X coordinates, which makes this negative 0.8. That makes this 0, and that makes this 4. And if we're going down 3, then we subtract 3 from our y coordinates, negative 4, negative 3, negative 2. Our vertical asymptote is what? Our vertical asymptote is what? X equals negative 1. Good. So let's graph these points, negative 0.8 and 1, 2, 3, 4. 0, negative 2, 3. 1, 2, 3, 4, negative 2. And I forgot to draw my asymptote. Can Can y'all see that? So, domain is -1 to infinity, and range is -infinity to infinity. Any questions here? Your homework is 1 through 16. 1 through 16. Your homework is 1 through 16.